Welcome back, and off we go to the races. Fall 20, Test 3, Part 4, Version 2, Retrosynthetic Analysis. We have to know that we're starting with benzyl alcohol that has the phenyl group. And please remember, this is the phenyl group right here. And it's attached to 1, 2, 3 CH2s. So phenyl, CH2. Oh, we got this C covered with our alcohol. Where are these other two C's coming from? They must come from acetylene. Okay. We learned a reaction that takes a terminal alkyne and converts it to an aldehyde. Show me you just know that you know of a reaction that can convert a terminal alkyne to this aldehyde, and show me what the terminal alkyne is. Make sure what you draw has exactly the same number of carbons as this. Do not add a carbon. Do not subtract a carbon. This used to be a triple bond. The triple bond got a new O here, and it got two new bonds to H here during the mechanism. So here is the acetylene portion. And then the remaining 1, 2, 1, 2, the remaining 7 carbons are the CH2 here and then the phenyl. So CH2, and you can use short forms for every section except for nomenclature. Okay. Now it's time to think about synthesis. How did you make this molecule from smaller molecules? You know how to put a alkyne acetylene portion attached to an adjacent carbon as long as the nucleophile is acetylide with an anion and the electrophile has a leaving group such as, and strongly suggested given the information above, CH2 phenyl. Bromine CH2 phenyl. And that is a backside attack on a carbon with a halogen to make that bond. This bond, sorry. This squiggle here is unnecessary, but I'm just showing you I know how to make that bond from these two pieces. That's what that means. These are not arrows, not reaction arrows. They're backwards arrows that say this came from this. This arrow means this target came from these two things. This arrow means the acetylide target, acetylide is this, came from acetylene. And you are allowed to stop now because acetylene is on the list. It's in red, acetylene. Now, you don't know this yet, but that's why I gave it to you. An alcohol can be converted to an alkyl bromide with the same number of carbons using this reagent here. It's a chapter 10 preview reaction. All we have to do is use that reaction right now. So this target here, yeah, notice my targets keep changing. Yeah, this was my original target. It came from this. Now this is your target. It came from these two things. This thing came from that. This thing came from an alcohol with the same number of carbons, also known as, what is the name of that alcohol? Phenyl CH2OH, right there. Benzyl alcohol, circle it. It's on the list of things you're allowed to start with. We'll go in blue. Benzyl alcohol. There you go. So you've done part A. Retrosynthetic analysis says, I know how to break this down to simpler pieces to make this thing. Now you go in the forward direction and tell me you know the chemicals needed to cause these transformations. What takes the H off of acetylene with high yield? If anybody says sodium hydroxide here, you get 0 points. That equilibrium doesn't go to the right, it stays to the left. There's a whole discussion of the 4 possible bases. H minus is my favorite because it's the smallest. It's easy to write. And it becomes H2. You don't need to show me the H2. I'm going to get rid of it. Inorganic stuff. Don't need it. Okay. Now, how do you make this into this? Don't shake your head. Copy what you see here. HOCH2 phenyl. HOCH2 phenyl becomes BrCH2 phenyl. Just use the chemicals I gave you right there, the chemical. Phosphorus tribromide. Okay. And then how does this molecule come from these two? Well, it's pretty simple. You got to make them meet. So how do we show that? Make them meet. I like using parentheses. You might have another way. I just say, hey, I'm going to combine those two. And when I'm done, I'm going to have this. Exciting new bond. That's the best part. CH2 phenyl. You're here right now. You've made this thing. What chemicals are going to make that thing into the target? We have to know those chemicals. And you got to let your teacher have some fun every once in a while. Copyright infringement. What chemicals make that into our target molecule? Well, something about boron. You could use BH3 here for partial credit, but it doesn't give good yields. With alkynes, it's best to switch to HB Sia taken twice. It's moving it over so it's not touching my alkyne there. And step 2, no, step 2, Lord, pen, blue, 2, KOH H2O2. You could write OH minus if you want. I need those two chemicals, OH minus and H2O2, and you make the target. If your target was a ketone right here instead, then the only thing that changes is this last reaction. You'd use the oxymercuration reaction. You'd use mercury 2 sulfate, water, and sulfuric acid, and you'd get a different target with a ketone right here on the second carbon. Look for examples of that. You will see many on exams. Okay, so this is an 8-point retro, and I took the larger one and moved it over here. You must still use this useful reaction over here. And let's see, this is a cis-alkene here, isn't it? You have to know that cis-alkenes come from internal alkynes with exactly the same numbers of carbons. So CH2 phenyl. How many CH2s? 1, 2, 3 carbons after. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. And now you're back to synthesis. You know how to make this bond or this bond. You choose. Doesn't matter the sequence. Let's see. I know how to make that bond as long as the C-triple-C is an anion. It will be an attacker. We call that a nucleophile. And the carbon that's getting attacked has to have a halogen on it, or else it won't react. Bromine. Guys, you're going to choose the halogen that the useful reaction creates. It's that simple. If I give you a useful reaction that converts an alcohol to an alkyl chloride, you're going to put a Cl here. Look at old exams. You'll see them. Sometimes he's doing Cl. Sometimes he's doing Br. Sometimes he's doing I. Trust me, you'll see them all on old exams. This molecule comes from these two. Whenever you have an anion of acetylene, whether it's acetylene with a group on it or a normal acetylene, it comes from an acetylene. Here, benzyl acetylene. You're not done with that. And this one here comes from 1-propanol. Circle it. Why circle it? It's on your list of alcohols of 5 carbons or less, and or benzyl alcohol. That's coming later. And acetylene. Okay. Now I know how to synthesize this bond. With 2 pieces? Well, it's always some kind of C triple C minus. In this case, just C triple C minus. And Br attached to benzyl, BrCH2 phenyl. And it's the same as our previous retro now. There's acetylene circled in red. And here is, this came from an alcohol with the same carbons. Circled in green. Benzyl alcohol. Not liking that bond, not touching the O. There. Turned color. Nice. Okay, forward synthesis time. You started here. You made a C triple C minus. Let's do it. Go purple. H minus. Use it every time if you want. C triple C minus. What's it going to react with? C triple C minus is going to react with benzyl bromide. You haven't made that yet. You better make it first. I'm going to take HOCH2 phenyl. HOCH2 phenyl. CH2 phenyl. And make it into BrCH2 phenyl. Using the exact same reaction I was given up here. PBr3. Let's copy it faithfully. Then I'm going to mix those two together. And that's going to make this target right here. C triple C. You're currently right here. And you need to make that into C triple C minus. Guess what base I'm going to use for that? Broken record here. H minus. Purple. C triple C minus. What piece does that react with? Well, this is going to react with this, but I haven't made this yet. I better make that right now. I'm going to take this 1 propanol and make it into 1 bromo propane. I'll do it in green. PBr3, you're getting a lot of points for just using the teacher's reaction. Then you're going to combine those two things. And you are going to make this species right here. Let's make it all green. It's got a propyl on one side. C triple C. 1, 2, 3. And then CH2 F. I don't like that. That's getting a little squirrely here. C triple C in the middle. CH2 F here. 1, 2, 3 here. And then the question is, how do you make a cis alkene from an internal alkyne? And you got 2 choices. The easiest one in terms of the amount of stuff you have to write, when we saw earlier in today's session. And we made our target. Okay. Okay. So is that good? I've stunned them into silence. That was good.
Yeah.
All right.
Okay.
Yes, sir.
I just need to practice these. Is it okay?
Yeah. It takes practice. So here's the deal. We can quit now, and I can save stuff and get the problem set done before I phone my mom. Or if we do another session, problem set's going to be later tonight. So you guys are in charge. I hate to put you on the spot like that. That wasn't very nice.
I don't think I have any more questions. I just need to go practice them.
You think you're okay?
Yeah, I guess.
How about you other guys?
Yeah, I think I'm the same. I just need to practice some of the mechanisms.
Yeah, you got to sit with them and forge them out. Have that textbook handy as your guide.
Quick
All
question.
right, guys. Yep.
So for the journal, to make sure we have everything, what would be the best way to like make sure we have everything?
I believe there's a list on the syllabus.
Okay.
So if there's anything in chapter 6, I want it in your journal. Anything in chapter 7. Don't worry about items that were in chapter 4. We're just going to say we're not doing those in a journal.
Okay.
So because our tests on 6 and 7, I want to see all your 6 and 7 mechanisms in your journal.
Okay. And those are the ones that are going to be on the test. So like we wouldn't have to
Yep.
know about. Okay.
Yep.
Thank you.
You're welcome. All right,
Bye.
guys. Take care of yourselves. Look for that problem set. I will send an email as soon as the problem set's ready, hopefully within 20 minutes. Take care.
Thank
Thank you.